the chemical makeup of that is not very friendly to our body cells. So um, here's a little bit of chemistry on the page, and don't get too freaked out by this, but I just like to show it for those who maybe want to understand this in a little bit deeper level. But when I talked about how we have solid, like fats are considered solid at room temperature and oils are called liquid at room temperature, it has to do with the shape of their molecule. So saturated fats are the ones that tend to be solid at room temperature. So we call it saturated because if we look at the molecule, these are carbon atoms. Fat molecules are made out of carbons, hydrogens, and oxygens. So the H's are for hydrogens and the O's are for oxygens, and then the C's are for carbons. And they're arranged in a way such that they're always like in a chain. They linked together like this. And then carbons they have like 4 little arms that can connect to another molecule. It can either connect to another carbon or to a hydrogen. And sometimes, like in this case, 2 of its arms can connect with an oxygen, because the oxygen's kind of hoggy. It likes more electrons to connect with, so it grabs 2 of them from carbon instead of just 1. So that's oftentimes that happens. In this case, it's only taking 1 and the other one is going to this hydrogen over there. But anyway, the structure of a fat is that it has a bunch of carbons linked together, and then on the end of the molecule, there's always this little group where there's 1 carbon attached to an oxygen there, and then attached to an oxygen and a hydrogen. And we see that over in this one and also in this one. They're all the same. So the only thing that's going to be different is how many hydrogens are there. So when there's a single bond between carbon atoms, that's like just 1 little bond between them. That means that in order to have a single bond, it means that each of the carbons have to be attached to hydrogens all the way around. And so we call that a saturated fat. It means it's saturated with hydrogen. And as a result of that, the molecule is straight. It can't bend at all. So it has a straight shape, which makes it somewhat rigid. And if you had a bunch of those joined, together in a food, they're going to kind of pack on top of each other. And that's why you can create a solid like this butter, or coconut oil, same thing. We also see it with the animal fats. Like, if you cook a piece of meat, when it's hot, the fat melts, but once it gets back to room temperature, you notice that it gets solid again. And so those are saturated fats that are in the meats as well. And so one thing about saturated fats is they're very stable, because they don't have, they're saturated with hydrogen. So nothing else can attach to this molecule. It's completely full with hydrogen. So that makes it very stable. Like the air can't really react with this because there's nowhere for it to react. In order for a reaction to occur, you would need a carbon that had a hydrogen missing and that had like an extra arm for something else to attach to it. And so that's not going to be the case with the saturated fat. It doesn't have that ability. So they're super stable. They can actually take some heat because of that. They tend to have higher melting points. So if you put them in a pan, you could crank the heat up to like probably like a medium to medium high. And it's not going to smoke. It's not going to go bad on you. It's not going to get damaged. And so saturated fats are actually, and I know this is contrary to everything we all have been told, but saturated fats are the best ones for cooking because they're stable. They're not going to go bad on you. So that would include things like coconut oil and butter. And then there's something called clarified butter, which is also known as ghee, which is basically just it's the oily part of the butter with all the solids removed. That's actually a really good cooking oil. It's good for veggies, by the way. Makes the veggies taste good. And then and palm oil. Palm oil is like a cousin of coconut oil. It's different type of palm tree. There's coconut palms, and then there's palm fruits, which are these little red looking, almost like a little apricot. but the inside flesh of the little palm fruit is reddish, and it has, if you press it, you get an oil out of it, just like you can press a coconut and get oil out of it. So it's a solid at room temperature, and it's a saturated type fat. And then these other fats, the ones that are liquidy at room temperature, this one is called a mono unsaturated fat, and it's called a mono because it's mono means one, and it has one location in the molecule where there actually is some hydrogens missing. And when that occurs, what happens is there's a little bit of a bend in the molecules. It's mainly because there's no hydrogens here to take up that space. So if there were, it would have to flatten out and straighten out. So, but because there isn't anything there, it just tends to kind of want to bend like that. And so that one location, there's actually two arms going between the carbons, and we call that a double bond. And the double bond, even though intuitively you might think, oh, that means it's stronger. There's two of them. It's holding it together there. That makes it stronger of a molecule. But in reality, it's weaker. It's weaker than the saturated fat because it's actually missing two hydrogens, which means that something can react with this. It can literally come in and try to react with this molecule and then damage it. So it becomes somewhat vulnerable now when it has a double bond. And when there's only one in the molecule, we call it a mono unsaturated fat. And because there's only one, if you look at this, you can see that most of the molecule looks very similar to a saturated fat, like this part and then this part. Like most of it is pretty well saturated. It's just this one spot right here that isn't. And so we say that these are semi-stable. You can cook with them at like low to medium heats. That's why you can use some olive oil at a low heat. Some other oils that are monounsaturated are going to be like avocado oil, macadamia nut oil. You've got sesame oil, I believe, is in this category as well. And yeah, those are pretty well most of the monounsaturated fats that there. By the way, canola oil has that as well, but canola oil has other issues with it where it's actually less stable as well. So we're not gonna put canola oil in the healthy category. But you know, it's pretty good. And then we've got the polyunsaturated fat, which has two or more double bonds in the molecule. This image is showing two, but there are some polyunsaturated fats, like for example, those that might show up in soybean oil or corn oil or safflower oil, sunflower oil, that there can be up to 6 locations along the molecule where there's a double bond. And then every time there's another double bond, it makes it more and more weak and more vulnerable, meaning that it really isn't good for cooking. If you heat it, it's going to get damaged. And so even though it's like complete opposite in our culture, we've been told that we need more of the polyunsaturated fats. We should avoid the saturated, use those polyunsaturated fats for all of your cooking purposes. And even though in foods, like in a seed, like if you eat seeds, if you eat nuts, if you eat grains, those polyunsaturated fats are what I call the good fats, because they're still in the food and they're protected. Once you press them out, they're now like away from their fibers, they're away from their antioxidants, they're away, you know, they're basically like naked. And then they're vulnerable to the light. You know, just the UV rays from the light can damage those double bond spots. And any kind of heat will definitely do that. One thing you guys will know, you'll relate to this. I'm sure you have seen this happen at one time or another with your cooking. If you put oil in a pan, if you've got your burner, and then you stick your pan right on top of the burner, and then your pan starts getting hot, and then you put your oil on the pan, and then you notice what starts happening with the oil. You notice that it actually kind of almost starts to move. Like you'll see it like shimmering. before it would get too hot. Hopefully it wouldn't get so hot that it would start smoking. But there comes a point where it actually literally starts shimmering, the oil does. And why is it doing that? What's happening is you're literally raising the vibration of the connections between the carbons and exciting it. You're exciting those electrons that are in there. And so that, because heat is energy, so you're just like applying energy, heat to this, and it starts to actually move. Those little bonds start to move. Now, if it gets too hot, what happens? It smokes, right? So what is the significance of that molecularly? Well, molecularly, it's because you literally broke apart a bond in the molecule, and now you've got damaged oils. And here's one way you can know whether you've damaged your oil is if when you're done cooking with your oil, it's brownish or almost black in your pan at the end. If that's the case, you know you heated your oil too hot and that it really damaged your oil, and you've probably got a bunch of free radicals now that seeped into your food, and that's what you ate. If your oil is still the same color that it was when you started with it, then you know you've kept it protected and it didn't get too hot. And that should be the case. It's a good visual, a good kind of rule of thumb. One little trick that I have to help with that is using a little bit of water. Let's say you're going to stir fry something. You want to cook some meat or something in some oil. If you put a little bit of water first in your pan, like here, here's your burner, there's your pan, and if you stick oil right on top of the pan, it's going to get hot really fast. And sometimes it's too hot, too fast, and it's beyond the point of being able to save it. But if you put a little barrier of water in the pan and then put the oil on top of that, you're literally putting a barrier of water between the pan and the oil. And so water, when it boils, can only get up to 212 degrees. That's the boiling point for water. Right? That's 100 degrees Celsius, 212 Fahrenheit. And so you protect your oil that way because you'll see steam coming off the water, but you won't see smoke coming off the oil. And you can tell the difference, and you can certainly smell the difference between steam and smoke from your oil. And your oil's protected, and then it's just kind of nice. Sometimes I just even try to use broth or water for the main cooking part of whatever, if I'm cooking some chicken or maybe some vegetables, and then I add the oil more toward the end of the cooking, more just to flavor it rather than actually using it for the cooking. That's if I want to use a polyunsaturated oil or a monounsaturated oil. If it's a saturated, it's okay. I can put it right on the pan and it doesn't really matter. So like when I cook eggs, I use coconut oil or ghee for that because I like to do a over easy egg sometimes. But